In this example, we're asked to state the transformations that are needed to be applied to obtain the graphs of the following functions from their parent functions. So in part A, we see that -3 is taking the place of A. Because it's negative, we have a reflection in the x-axis. And then the 3, since it's greater than 1, it represents a vertical stretch by a factor of 3. The 4 is taking the place of k. Because it's greater than 1, it represents a horizontal compression by a factor of 1/4. Remember, for k, you always have to take the reciprocal to determine the factor. And then the 5 is taking the place of d, and it represents a horizontal translation. And it'll be 5 units to the right. Finally, 1 is taking the place of c, and it represents a vertical translation. And in this case, it's upward because it's positive, so 1 unit up. Okay, let's look at another example. The 3/4 is taking the place of A. Because it's between 0 and 1, it now represents a vertical compression by a factor of 3/4. The -1/2 is taking the place of k. Since it's negative, we have a reflection in the y-axis. And then the 1/2, because it's between 0 and 1, is actually going to be a horizontal stretch by a factor of 2. Again, we're taking the reciprocal of the k value of 1/2 there. The 10 is taking the place of c, and it's going to represent a vertical translation 10 units to the right. To the right. Okay, so now we're going to look at example number 2. And in example number 2, it says, write the equations that would result from applying the following transformations. So we're given the transformations and we have to write the resulting equation. So here we have a reflection in the x-axis and a vertical stretch by a factor of 4, a reflection in the y-axis, a horizontal stretch by a factor of 2, and then a vertical translation 6 units down applied to parent function of f at x is equal to 3 to the exponent x. Okay, so our new function, we can call it g at x. We start with an a value. And since we have a reflection in the x-axis and a vertical stretch by a factor of 4, the a value would be -4. Then the base would follow in brackets, and we know from the parent function the base is 3. Then we look at the exponent, starting with the k value. Since we have a reflection in the y-axis and a horizontal stretch by a factor of 2, the k value would be -1/2. And we don't have a horizontal translation, so the -1/2 is simply going to be followed by x. Then we have a vertical translation 6 units down. That means our c value is going to be -6, and it will appear at the end. In part B, we have a reflection in the x-axis, a horizontal compression by a factor of 1/3, and a vertical translation 12 units up applied to the function f at x is equal to 1/4 x. So a reflection in the x-axis means that the a value will be negative. It'll be -1, and the 1 could be left as implied. the base follows, and it's 1/4 from our parent function. And we work on the exponent. It says here that we have a horizontal compression by a factor of 1/3, making the k value 3. Again, in this case, we don't have a horizontal translation, so the 3 can just be followed by x. Okay, and the last thing that we have is a vertical translation 12 units up. That means c is going to be positive 12, and it will appear at the end. If I, for example, added a horizontal translation, so if I put here plus horizontal translation, 5 units to the left, okay, then the function would change slightly, because now we would have to add d. And d is the value that's going to follow the x. Since it's 5 units to the left, that means d is -5. So I'm subtracting a -5 from x, which in fact is the same as adding 5. So that's what it would look like.